When speccing out a Proxmox or other home lab virtualization server, I typically recommend that someone maxes out on their RAM first. But in the RAM apocalypse of 2025, if you don't already have a big collection of RAM laying around, that is now a lot more expensive than it was before. So today I want to take a look at alternatives in Proxmox, and probably is a little bit generalizable to other workloads too, of how to get the most out of your existing RAM, and how to try using technologies like swap and memory compression to try to get a little bit more out of all those precious sticks that you already have in your system to possibly push off that RAM upgrade till later, or get away with a lower tier of RAM than you otherwise would need. Now, I want to start this video off with a little bit of a talk of why do virtualization workloads like Proxmox typically need so much RAM and have so much recommended to it. First of all, with virtualization workloads, you're often running a lot of different OSs and other libraries. In a traditional kind of desktop or environment where you might only have one OS running at a time, that's only one kernel and one set of drivers you're running at a time. But in a virtualization workload or a container or Docker workload to a slightly lesser extent, you're going to be running multiple kernels, multiple libraries, multiple drivers, and more. And running all of these requires a little bit of RAM for each of these, and that can all add up really quickly. Especially with the next part, which is that often home lab servers are running at a relatively low amount of load. And what this means in practice is a lot of those servers use the minimum amount of RAM that they need, but they don't really scale up in terms of things like CPU. So this means they might need a half a gig of RAM all the time, but need very little CPU. So it's really easy to just put a lot of little services that each need a bit of RAM, but very little CPU, meaning that you have a very high RAM usage compared to CPU. The last one is caching. While disks, especially like these, are pretty fast, one way to speed up especially slower drives like hard drives is to just put a bit of RAM in front of it. So that way it can try to adaptively cache what it thinks you might need next, and cache files that you've already opened thinking that maybe you'll need them again, and it'll save the time having to go to disk. And this can often be cheaper than buying something like these Optane disks or other high-end storage that is going to be the faster backing storage you could otherwise get. ZFS is commonly talked about using this, but there's a lot of other technologies, and almost every modern OS will try to use free RAM as disk cache to try to speed up disk I/O on your system. And with virtualization also liking quite a bit of disk I/O, RAM can be an easy way to essentially speed up your disk I/O in your system. One quick thing I want to note in Proxmox is the way that the out-of-memory killer works. Linux has an out-of-memory killer that will stop VMs before it runs out of memory on the system. But in Proxmox, this will just happen and not be told to the user at all. So it won't appear as one of the tasks or cluster logs below, and it just isn't obvious to the user. So in my general rule of thumb is if I see memory very high, and if I see a VM that seems like it should be running, but without any logs or anything telling me it's stopped, that's likely the out-of-memory killer, and I want to take a closer look at memory usage and likely play around with swap or something so that the out-of-memory killer can't come in. I'll talk a little bit more about swap later on, but that's just something you should be aware of. The out-of-memory killer can be active in Proxmox, and it doesn't tell you very well that it is active. Now let's take a look at some methods to get the most out of all the precious RAM you have on your system in front of you. Now, in order to help demonstrate all of this, I took these 3 sticks out of my main home server. I did a previous video about turning it into an R230. So that means I'm running all my loads on 16 gigs of RAM instead of 64. And with a little bit of tweaking, as I'll show in a bit, it's running pretty fine on a quarter of the RAM, which I think might be enough workloads for quite a few people. So let's take a look at what's going on here. First of all, minimizing the amount of GUI RAM usage. A lot of the time, GUI interfaces like the Windows interface or GNOME or some of these are quite memory intensive that aren't doing much for a home lab server that likely isn't going to be in the GUI that much. So if you need a GUI, I'd try using a lightweight GUI, so something like LXQT or XFCE on the Linux side, possibly removing the GUI or disabling it by running by default if possible. Or on the Windows side of things, Windows Server typically uses less memory than the Windows 10 or 11 or other desktop variants. And Windows Server has a minimal install, which is kind of a CLI only, but a GUI that's in a window you can only run the command prompt. So all of those should use less memory, and depending on your application, give you similar functionality if you're not using that GUI anyway. The next thing I typically want to do is to try to minimize the amount of extra memory that VMs are using. So by default, if you give a VM, for example, 32 gigs of RAM, it'll treat it like a desktop PC would, which is where it sees I have access to all this RAM. I might as well use all of it for caching, or programs will grow to use more because it's essentially free, because unused RAM is kind of wasted RAM. But in this case here, you want to try to change the programs into thinking that unused RAM could be used for other VMs or other workloads, so it's not wasted, and they should only use it for what they need to use it for. So I like to start this by, first of all, just cutting back on the amount of RAM allocated to a specific VM. So for example, while a VM could have 16 gigs of RAM, but if it's only using less than 8 most of the time, so for example, if I have the guest agent set up, I can see that like this DC6 VM is only using half a gig out of 4 gigs of memory. That means I likely don't need to give it 4 gigs. Now, some systems have system requirements and it might need more during updates and other things you should be aware of, but I would typically refrain from giving VMs significantly more RAM than they typically need, as that means they could allocate it and take it from other VMs if needed. The next thing I like to typically do is to turn on ballooning. So this requires using the guest agent, which is inside the VirtIO CD disk, and then going under options, and then under QEMU guest agent, turn it to enabled. Once the guest agent's enabled, you can now go under memory and then turn on ballooning device. And what this ballooning device will do is it'll essentially be in the VM and it'll try to suck up the unused memory and hand it back to the host. So one great example I have of this right now is my Veeam backup VM right now. So on this system, it is using 6 gigs of memory right now, but all this standby memory that's not being used, if I take a look at my host right here under summary, I can see it's only using roughly that 6 gigabytes of memory on the system. It's not using all 16. And these extra 10 gigs of RAM could be used by the VM if they needed, but they're not being used because the VM doesn't need it, and the ballooning device is essentially grabbing that memory back and handing it back to the host to be used for other VM. And the last thing that's probably actually the biggest difference here is use containers if possible. Containers are generally going to be a lot more lightweight than VMs because they don't need a desktop interface that's optional, the full virtual PC, a separate kernel, separate drivers, and more. There's much less code running in a container compared to a full-fat VM. So for example, a basic Debian VM might be half a gig of RAM, but a container is 50 megs. And if your services are using the same kernel version as the host and don't need to use kernel modules, add-ons, or anything specific to the kernel, it could be a great way to save a huge amount of memory, especially if you're running a lot of small workloads, like multiple small web pages that only need a handful of memory for the actual web server, but a good amount of memory for that base OS. And also generally much better at sharing memory from the host, as you don't need the ballooning device, it's just another process on the Proxmox host. Now that I've gone over tweaking your workload and some Proxmox settings to minimize the amount of RAM used, let's take a look at adding some virtual RAM using either block devices as swap or memory compression to squeeze more memory in your memory. Now, at first glance, some of you might be thinking, page file and caching out VMs, isn't that going to kill the performance and latency? And in certain critical applications, it certainly can and should never be considered. But I have found for a lot of home lab applications where you likely want to run a lot of relatively low use VMs, are trying to do it on a budget to minimize purchasing this extra RAM as long as you can, I have found and ran in my personal servers for a while that you can allocate quite a bit of swap, as long as you follow a couple kind of guidelines I like to follow, with very minimal performance hits, because there's just a lot of parts of VMs that are running that are kind of idle, can be swapped away with very little impact. And as I have it set up right now, I have a lot of VMs running on a system with 16 gigs of RAM. I took out these extra sticks just for testing, and on 16 gigs of RAM host, I have multiple Windows Server VMs, a router, and many different Linux little VMs running their workload, and it's running relatively fine. So let's go over some of my guidelines, default swap settings, and then go over some more of the technical, how I can actually set it up in the command line in Proxmox. Now, my guidelines for setting up swap on my Linux systems involve, first of all, getting as good of a swap device as I can. So either memory compression, I'll talk more about later, or using a relatively high quality SSD. Optane is kind of the best of the best if you can get it. Otherwise, enterprise class SSDs, especially NVMe if possible, are quite good, or high-end SATA SSDs like an S3700. I would typically stay away from anything that's like DRAM-less or QLC, because those can have latency spikes, which can really slow down the system if it's just waiting for page files and stopping everything else. The next thing I like to do is take a look at my system, monitor on my system, to try to figure out how swap's being used. A lot of the times VMs, like on my system right now, I have 21 gigs of swap allocated right now. But what I like to use is dstat right here, which has information on how much data is being paged in and out of swap. If this page usage is really high, that means the system is moving a lot of data in and out of swap, and it's likely going to be waiting for that data to come in and out. But looking on my system here, this is in bytes. This is really low. If it's in bytes or kilobytes, I kind of see that as a non-issue, but when that starts dropping into the megabytes, that is likely going to be a problem. The next thing I like to do is look at my disk I/O usage. So below this is IOStat, part of the systat package, and I can see this NVMe 1-in-1 device. This is another one of these Optane drives in my main server, and I see its usage is 0.60, almost nothing. If this starts to go up, the latency for these drives will also go way up as the usage goes up, and that again can cause slowdowns. So general rule of thumb, high quality drive, relatively low amounts of I/O going in and out of paging, and if you don't notice any problems, you're likely good to continue using swap in your workloads, and I have personally on my home lab servers had relatively little issue. Now, I want to talk a little bit about how Proxmox sets up swap by default, so you get a better feel of what's your starting point when you have a new Proxmox system. A lot of this depends on how you configured your Proxmox's boot storage. Proxmox either has the file system storage like ext4 or XFS, which just uses traditional partitions with the file system on it, and it will make a bit of swap configurable in the installer. Or you can use LVM with, again, swap configurable in the installer. The next option you can use is ZFS, and that by default will have no swap set up. If you're familiar with ZFS, you might want to use something like a zvol, which is a virtual block device. Taking a look at my server again, I can see all of these ZD devices, so zvols, that were created for my VMs to use. But in some in some IO heavy workloads, those can have problems, so you shouldn't use those for swap because of that. If you want to use swap on a boot ZFS device, I would typically shrink the partition in the installer and use that extra little bit as swap. It's probably optimal if you're using swap a decent amount to have a dedicated drive if possible, or a separate partition. One thing to note that's kind of an oopsie is on my configuration is allocating swap does take a bit of memory to tell it essentially where all that swap is and what bits it can use. So if you think you're only going to use maybe 20 gigs of swap, make a partition that's just a little bit bigger and don't just allocate a whole SSD, because now all that extra space will have to be managed. And you can make that partition a little bit bigger later on if needed for it. The next parameter to take a look at inside of Proxmox, and any Linux system for that matter, is swappiness. Swappiness in Linux is the parameter that determines how likely the system is to move something out to swap prematurely. So if it's set to 0, for example, it will only swap out due to an out-of-memory configuration. If your goal is to never have your Proxmox system swap out, I'd actually have a bit of swap and set it to 0. And that way, when you go in your system and take a look at the summary tab here, if you see any swap usage, that means it had to swap something out because it was preventing an out-of-memory situation. Even though there might be a bit of a performance hit, this can be an easy way to tell you probably need more memory without Proxmox actually killing the VM and stopping a potential critical workload you want to run. By default, this value is set to 60, and higher values make it want to swap out prematurely more likely, and lower values means it will swap out less prematurely and only if it has to. You can set this value in etc syscontrol. It might be empty if you have a new system, so create the file and add the line here as recommended in the PVE admin guide. In all of this swap I've been talking about using a block device like an SSD here as swap, but there's actually another type of block device you can use, which is more memory using memory compression. This is all built upon a program called Zram in Linux. It essentially makes a RAM disk into a virtual block device, but instead of just storing the bits, it will compress it. And because a lot of what programs store in memory, like VMs, is relatively compressible, you could take, for example, 8 gigabytes of what VMs are storing, compress it into 4 gigabytes, for example, and that will save you quite a bit of space at the cost of the CPU cycles to compress it, and a bit of latency if it wants to access it, has to go decompress it. This isn't an either or type of thing, so you can actually use memory compression and have a bit of memory set aside for compression, and once that's filled, it can move it to a other block device as well. There's a lot of tuning that goes into figuring out what possibly could be the best for your workload, but my kind of gut is take a look at what type of block device you'd possibly want to be using as swap. In my case, I have these Optane drives. Because these are basically the fastest swap drives on the market, I'm just going to use this and forget about memory compression, especially since I have a relatively slow quad-core CPU. But perhaps you're on a dual-socket system or something with a lot of cores or extra CPU power, and maybe you only have SATA drives. In that case, I'd be looking a lot more towards starting with memory compression and then using swap later. I've looked into creating tests for trying to figure out what the best swap device are, but like a lot of caching, it's really hard to benchmark well, and I haven't had a way to get a number that I really feel like posting in those tests. Let's take a look at configuring either of these methods, starting off with memory compression. Zram is a pretty powerful little program that lets you set quite a few parameters on how you want to do it, and you can look at all the kernel things and do quite a bit, but the simplest way to just get it started on your Proxmox system, which is built upon Debian, is taking a look at the Debian wiki. So start off by running sudo apt install zram tools. Once you install zram tools, there's going to be a new config file in etc default zram swap. And there's 4 lines here that are being shown. The first one is the algorithm. There's lots of different compression algorithms. So typically ZSTD by default is going to need a bit more CPU, but have a better compression ratio, so squeeze it smaller. But LZ4 uses less CPU, but doesn't compress quite as well. Because I'm on a slow quad core, I'm going to stick with the default of LZ4. Percent is the amount of RAM that should be used for ZRAM. So that means it can use half the memory. So in this case, 8 gigabytes of memory. You can also set a static device, but the percent will override it. So this size is actually currently doing nothing. And then priority is setting the priority of the swap device. So in this case, a higher number is more likely to be used first. If you cat or view whatever is in /proc/swaps, you can see what's going on. So on this system, the ZRAM device is set to a priority of 100 and is fully used up. And then my other Optane drive, which is NVMe 0 and 1, is set with a priority of -2, and any other swaps needed is used after that. If you have multiple swap devices with the same priority, it will be striped or essentially RAID zeroed between those different devices. As a little comparison, it says it's allocating 8 gigs, but it's only seeing 3.3 gigs of data. So likely sparse data is being stored on swap as a way of saying you need memory, but it's not actually storing any data. It's compressing those 3.3 gigs to 1.5, saving me about half the space the RAM's that's using, but again at the cost of CPU cycles and latency. Once that file has been set up, you can do sudo system control zram swap, and it will apply those settings and create the swap device and start swapping out with the memory compression. You can also reboot the system and it will apply and set it by default without having to dive into config files and init files and making it all work on your system. And if you want to disable it, you can run sudo system control disable zram swap. You can run system control stop to stop the swap service, or you can disable it. I will note that stopping swap on a running system takes time to copy it all off and potentially more memory, so I'd probably just disable the service and reboot if possible. Now let's take a look at configuring swap devices. So typically what I'd want to do is create a partition or a full drive, depending on how big the drive is, that I want to use as swap. Once I've allocated that and found out its name, running something like lsblk on my system. So in this case, I have NVMe 0 in 1 that I want to allocate as swap. I can do sudo mk swap and then a device name. So in this case, NVMe 0 in 1. So that is now going to be my swap device, and it's going to make it a swap. I can manually do a swap on, where it will tell it to turn on immediately, but I want to set this to run by default. So I'm going to use fstab to do that. So I'm going to do sudo vim/etc/fstab, and this is going to control where it mounts stuff on boot, and also swap is going to be mounted. And I'm going to also run sudo blk id. BOKID will show me all the block ID devices of all the drives on my system, as those don't change between reboots, like the NVMe 0 and 1 can change to NVMe 2 and 1 possibly between reboots. So on my system here, I've seen that this UUID device is the drive I want to use for swap. Because it's not a traditionally mounted system, there's no mount point. I want to tell it to swap. I'm going to say defaults and then 0 space 0. I can then reboot the system for this to apply, or I can do sudo swap on -a and it'll apply whatever my swap settings are that I tell to apply at boot immediately and mount that swap. Once I've taken a look and set up my swap, I can see under htop right here how much swap I have used on my system. I can then use programs like dstat to see how much is changing and just kind of get a feel for the system. A lot of tweaking swap for something like a home lab can be tweaking if you want to try to truly get the most out of your system. But as I've said before, relatively fast swap device, relatively idle workloads, I've found led to a way of getting more out of an existing server, and I can cram more of my VMs on it. I wouldn't want to do this for a customer's workload or latency critical, but I like to run a lot of VMs on relatively slow systems, and this can be a way to save a buck, especially now. Have you tried working with swap on Proxmox or memory compression? What's your experiences been with this? I'd love to hear in the comments below how you've set this up or what your experiences are, and how it's been working for you. Thanks for watching this video, and hopefully this lets you get a little bit more out of your memory you have now when the prices are still really high. Thanks for watching.